For any triangle, let's say we were randomly given a triangle, right? So, and then you know the side length A, B, C, these are all given. So once the side length of all three sides are given, that triangle is set, right?
Yeah.
There's no freedom to that triangle. You can't change anything. It's solid there. So that everything's set. So if I pick a midpoint here, that length should be set, right? So what's that length?
In terms of.
In terms of ABC. Because ABC would determine a triangle, right? So that triangle is unique. And then this length should be also unique, right? So if I say this is A, this one B, this one is C, I would make that point as M, so that this is lowercase c, so that's the length of the base. How do we find out Cm? So theoretically, if a triangle is set, we should be able to find the length of anything that is well defined. Let's say if I pick a point there, I say the ratio of this to that is something. I mean, we should be able to find the length of that line as well, right? So this is a special point because of the midpoint. It's relatively easier to find. So what would you do to find the length of Cm?
Using straight edge and compass?
No.
No. I think like log cosine would work.
Yeah, probably.
And you can find an angle.
Right now, the challenge here is I don't know the angles, but still you can avoid that.
But you can find angles with log cosine. Log cosine
Yes.
is when you don't have any angle.
So the sides are set so that the angles the angles are also set, right? So if you really just want to know the angle, or let's say I want to know what angle A is, and well, based on the cosine law, you still remember the cosine law?
No.
A squared equals B squared plus C squared minus 2BC cosine A. That's the cosine law, right? So remember we talked about the Pythagorean theorem is a special case of the cosine law, right? So that's when A equals 90 degrees. So when A equals 90 degrees, when the angle is 90 degrees, so here's an angle,
Zero.
here's an angle, cosine alpha, or in this case is A, cosine alpha equals this length over that length, right? So as the angle becomes bigger and bigger, let's say if you move that point along that line, right? So as the angle becomes bigger and bigger, it gets closer and closer to 90 degrees, you would see that this length gets closer and closer to that length, right? When it hits there, they're equal. And because cosine A, or cosine alpha here, is just the ratio of this length over that length, right? So that cosine 90 degrees is just 1. Sorry, am I saying, I said it the opposite way. I was talking about sine alpha. Yeah, cosine alpha is this over the hypotenuse, right? So as this gets closer and closer, this length gets shorter and shorter, right? And it disappears when this hits 90 degrees. That becomes 0, right? So that's cosine. So this part would disappear, and then we have a squared equals b squared plus c squared. Okay? So a squared equals this squared plus this squared. That's when this is 90 degrees. That's a special case. So if you really want to know what that angle is, we can rearrange this. So let's say if you move this over to this side, you get this 2bc cosine of a equals b squared plus c squared minus a squared. And then you divide both sides by that guy, you get 2bc here, right? Or if you understand that, oh, we can actually say arc cos this thing. That's
and
the,
then,
that's the angle.
wait, once you find the angle, you can find the height, and once you find the height, you can, right?
Yeah,
Like-
if you know the angle, you'll know the height.
And then you'll know and then you'll know how it splits BC. So then you'll know like every angle. So if you you want M, right?
I want to know the length of CM,
Yeah.
right?
So then, because you know H and you know, like you know like, like this thingy, and then you'll know this thingy. So then you'll know this thingy, and then you'll all like and then you know this angle, you'll know that angle, and then after you'll know this angle.
Yeah. So yeah, that's right. So if we just do it that way, like Zypher just said, right? Because we know what B is. Now, if we say we have this, we should know what that angle is, right? And the height here, the C, let's say the H, CH, well, that's the height, the altitude. Then that would be B times sine A, right? That would give us CH, that length, right? And because we know that length already, so that we'll know what this is, right? You just use the Pythagorean theorem. We'll know length of BH. And because this is half of C, so half of C minus BH would give us the length of that, right?
Yeah.
So, and use Pythagorean theorem again, this squared plus that squared equals CM squared. And we get what CM is, right?
Yeah.
That'll work. So, but there's a lot of calculation in there, right? And there's the accuracy problem and all that. So that maybe we want to see if there's a different way to do it, right? Let's see if there's a different way. So we'll still use the cosine law, but I'm going to use it this way. So here's an angle, all right? So this is C over 2, this is C over 2, because that's half of C, because that's the midpoint, right? And let me just say that this angle is angle alpha, right? That's angle alpha. So based on the cosine law, a squared should be equal to, let me say this is d, right? I want to find the length of d. So that should be d squared plus c over 2 squared minus 2d times c over 2 cosine alpha. Right? That's the cosine law. And then b squared equals d squared plus c over 2 squared minus 2d times c over 2 cosine 180 degrees minus alpha. Because that's the other angle, right?
Yeah, and then two equations, two.
All right?